Welcome to this explainer. Today, we're diving straight into a hidden slow-motion crisis that's literally engineered into the very foundation of the world's largest power station, the Three Gorges Dam. We aren't talking about sudden, unpredictable earthquakes here. The data we're looking at reveals a far more insidious, systemic threat, one that practically guarantees massive, long-term risks to millions of lives and absolutely critical infrastructure.
So, let's kick things off with a number. 97. In just the first 4 months of 2010, the Three Gorges Reservoir area experienced 97 significant landslides. I mean, think about that. That is one massive movement of rock and debris sliding into the reservoir every 30 hours. And crazy enough, almost no one outside of China heard a whisper about it.
Because here's the truly terrifying part. This wasn't some freak one-off event. It's a permanent reality. Just before that monitoring period, back in May 2009, 2 incidents dumped up to 50,000 cubic meters of rock right off a cliff in a single plunge. Just imagine the volume of 20 Olympic swimming pools filled with solid, heavy rock falling into a flooded gorge all at once. This is way more than just a localized erosion problem. The reservoir is actively engineering the exact conditions for its own violent destruction.
Let's get right into part 1, the engine of destruction.
To really understand why this landscape is falling apart, we literally have to look at how the dam operates. It runs on this massive 30-meter annual water level cycle. During the summer flood season, water is held low at 145 meters. Then, by winter, they crank it up to 175 meters for power generation. Finally, it drops back down. This massive fluctuation acts like a giant, relentless pump, forcing water deep into mountain cracks and fundamentally fracturing the geology year after year.
The physics of this cycle are just devastating. When the water rises, it completely saturates the hillsides, massively increasing the weight of the dirt and soil while destroying the friction that holds the rock together. Then when the reservoir water recedes, the hillside abruptly loses all that structural water pressure that was essentially propping it up. So you're left with millions of tons of heavy, waterlogged limestone, shale, and clay sitting there completely unsupported, just waiting for gravity to take over.
And the result of this cyclical saturation? It's created a catastrophic landscape. Current measurements reveal an absolutely staggering reality. 80% of the land in the Three Gorges area is actively eroding. This isn't a future risk. This is an ongoing collapse right now. The regional geology here was simply never meant to be submerged and drained like a giant bathtub.
And we're seeing this failure highly concentrated in hyper-vulnerable zones. Take the Zigwe area, which is right near the dam itself. Landslides tightly cluster near deep fault lines that now have a direct hydraulic connection to the reservoir. Or upstream in Badung, where the geology features weak rock layers and these things called karst conduit systems. It's basically porous, sponge-like limestone full of natural underground caves. Water infiltrates those tunnels perfectly, dissolving the rock from the inside out until the entire hillside just gives way.
Which brings us to part 2, the reservoir tsunami risk.
All of this structural failure sets the stage for a terrifying phenomenon known as a displacement wave. Because the Three Gorges Reservoir is essentially a narrow, 660-kilometer-long channel, massive landslides forcefully displace the water, generating monstrous, high-speed reservoir tsunamis. The channel averages just 1.1 kilometers wide, meaning these massive waves have nowhere to dissipate. They're basically trapped, putting riverside communities directly in their destructive path.
And we know exactly how devastating this can be from historical precedent. Back in 1963, over at the Vajont Dam in Italy, a massive landslide triggered a displacement wave that overtopped the dam by an unbelievable 250 meters. I mean, just picture that in your head. A wall of water 2.5 football fields high, launching completely over a dam structure.
That single, horrific wave wiped out the valley below, resulting in approximately 2,000 human casualties. This is the exact, literal apocalyptic scenario threatening the Three Gorges today. A localized, high-speed collapse could instantly flood riverside communities and completely devastate critical infrastructure, both upstream and downstream, in a matter of minutes.
Our source material points this out perfectly, and it's pretty chilling. A sufficiently large landslide can defeat a dam without touching it. The Three Gorges is a massive gravity dam, sure, but that core principle remains terrifyingly valid. The immense concrete strength of the dam simply doesn't matter if a localized geological collapse just launches a tsunami straight over the top of the whole thing.
Moving right along to part 3, sinking a downstream megacity.
Now, while those upstream waves threaten immediate, violent destruction, a quieter crisis is happening too. This landslide issue triggers a massive sedimentation crisis. 40 million tons of sediment enter the Yangtze annually, and as these continuous landslides dump even more debris into the slow-moving reservoir, all that sediment gets trapped. Locally, it ruins flood control and power generation, but downstream, it creates a severe sediment deficit, effectively starving the riverbanks of the silt they desperately need to survive.
And here is the major global consequence of that. Shanghai. It's located 1,600 kilometers downstream, sitting right on a massive sedimentary plain. It relies entirely on that arriving Yangtze silt for its geological foundation. By trapping the sediment, the dam is literally starving the foundation beneath China's largest economic hub. It's leaving a massive megacity highly vulnerable to destabilization over time.
Which leads us to our final section, Part 4. A slow-motion systemic collapse.
Look, authorities know this is a massive risk. They've deployed huge arrays of remote sensing, GPS, and satellite imagery to monitor those 660 kilometers of steep banks. They evacuate communities, they reinforce slopes. But honestly, you have to ask yourself, given that landslides happen suddenly across vast, remote, mountainous terrain, how many invisible cracks are propagating through those hillsides right this very second? If they detected 97 slides in that 4-month window, actually, think about how massive that area is. We're left wondering what unseen infrastructure dangers are creeping along entirely undetected.
We really need a total paradigm shift when thinking about this. Earthquakes might be the dramatic events that capture all the media headlines, sure. But these relentless, cumulative, and accelerating landslides are the true, inherent engine of destruction here. Every single year, the reservoir is actively degrading from the inside out, fundamentally weakening the surrounding terrain.
The source material hits the nail on the head with this profound distinction. Managing is not solving. You can spend immense resources on reinforcements and evacuations, but you cannot fundamentally solve a systemic flaw that is structurally baked into the dam's daily operations. The terrain is systematically destroying itself by design.
So I'm going to leave you with this final, chilling takeaway to ponder. If this dam fundamentally relies on a mechanism that absolutely guarantees the collapse of its own landscape, threatening fatal tsunamis upstream and the destabilization of Shanghai downstream, is a catastrophic systemic failure just a matter of time. Can human management ever truly outpace geological inevitability? Thank you so much for joining me for this explainer.